Question 3 from the midterm. This is a geometry question involving triangles. The first one here is just looking at three sides of a triangle, and they're asking, can you have a triangle that has one side of 18, another side of 10, and a third side of 7? Now, it's nothing to do with right angle triangles or anything else. It's just simply, could you have a triangle with those lengths? Well, the key thing to appreciate is you can't, because the reality is that 10 and 7 just would be too short. And if I was to actually lay a 10 and a 7 next to each other, or alongside the 8, you'd find, with pivots obviously at the ends of the 18, you'd find they wouldn't even meet, let alone make a triangle. So, in terms of you being able to explain in the question whether it is possible to construct a triangle, you simply need to put the point that the two shorter sides, the sum of the two shorter sides, need to be greater than the length of the longest side. The sort of theorem description is no side will be longer than the sum of the two opposite sides. Moving on to part B, we have a diagram here of two triangles, and there's various different lengths that we've been told and certain sides we don't know about. What we do know is these two angles are equal to each other. Now, if they're equal to each other, we have a situation where we've got alternate angles, mean that straight away we would be able to say, well, these two sides here are parallel. What you're basically expected to realise is you have two triangles, one bigger and one smaller. So in terms of its lengths, the smaller one has y, 2 and 4, and the longest one we have, a bit larger one, we have x is the longest side, 7 is the next shortest, and 2 the shortest. Before I go any further, I'll point out to you that just because it looks a bit like a right angle triangle, they look like right angles there, it doesn't mean that it is. So what you can't do is just go through the process of doing Pythagoras. Okay, you're not being told that these two angles are right angles, therefore you can't go down that process. You have to use a process involving similar triangles. So we know we've got a pair of sides here, the 7 and the 2. So if I want to work out x, I know we've got a scale factor to go from 2 up to 7. Well, what's that scale factor? Well, the scale factor is going to be 7 divided by 2, which is 3.5. So I know that, therefore, this unknown side is going to be 3.5 times the size of that side 4. So x is going to be my scale factor multiplied by the corresponding side that I know. And I get the answer of 14 for that. There's no units, so just leave it as 14. In terms of y, well, we're actually going in the opposite direction. So we want to know from this shorter triangle, we know its corresponding side is 2, and we've got a scale factor that goes from 7 down to 2. So in the exact same way, let's do it in a different colour. So my scale factor for this next one is 2 divided by 7. And my y value is going to be, I'm going to take that 2 that I've been given, that corresponds to the y, and I'm going to multiply that by whatever my scale factor is. So I get 4/7. Now I'm not even going to bother getting a calculator out, it doesn't matter, it's 4/7, 4/7 of a unit. And finally, for part C, we have a question where again there's two triangles, just that one is on top of the other. So we've got a smaller triangle and we've got a larger triangle. Now, one thing I would say to you again, they have not told us that it is an isosceles triangle. They've not told us that this side here is equal in length to this side here, and they've not told us that this side here is equal to this side here. So we can't assume it's isosceles. It'd be lovely if we could, but we can't. So we have 6 minus x 11 minus 6. And for the large triangle, we've got x plus 5, and we've got the sum of these two. So if you actually look at the sum of these two algebraic expressions, if I was to add those up, let's do that to one side. I've got 4x plus 4, and I've got minus x plus 11. Well, that gives me 3x plus 15. So 3x plus 15. And so we've got these similar triangles, and we need to work through what the lengths are. Well, the scale factor that we're dealing with here, let's go from the small to the large, is going to be x plus 5 over 6 minus x. But likewise, I could think of that's in terms of me looking at these two lengths. They're corresponding. If I go from the small triangle to the large triangle, I've got a scale factor of going from 6 minus x up to x plus 5, sorry. So the scale factor is the division of those, x plus 5 divided by 6 minus x. Well, the same thing can be done with the second pair of sides. Going from 11 minus x up to 3x plus 15, I can say the same thing. It's the same scale factor, and so I have a situation where this scale factor is also equal to 3x plus 15 divided by 11 minus x. And we now have ourselves a fraction equal to a fraction. And this expression here, we can cross multiply to be able to solve the equation. So I'm going to multiply this numerator by the opposite denominator and this numerator by the opposite denominator. Effectively what I'm actually doing is I'm multiplying everything by 6 minus x and also everything by 11 minus x. So, when I work through that, I will then to open up the brackets. We've got 18x minus 3x squared plus 90 minus 15x. So we just tie this up a little bit. Left hand side we've got 6x minus x squared plus 55. On the right hand side we've got 3x minus 3x squared plus 90. If we bring everything over onto one side, we get plus 3x squared, and we've got the minus x squared. We've got plus 6x minus 3x, and we've got the 55, take away 90. So 2x squared plus 3x minus 35 equals 0. Factorising that expression, or you could use the minus b formula. So for me, what two numbers multiply together make minus 70. How do I get that number? Very quickly, I'm multiplying 2 and minus 35 together, and these two numbers that I want have to add together to get 3. Well, I can see that 10 and minus 7, if I multiply them together, I get minus 70. If I add them together, I get 3. So I split up my x term into minus 7x and plus 10x. I can then factorise the first two terms, x is a common factor. Second two terms, 5 is a common factor. You'll see that what I have in the brackets is the same, 2x minus 7. So it's factorising correctly, and I have x plus 5, 2x minus 7, equaling 0. So either x plus 5 must equal 0, in which case x is minus 5. Although one has to say, if you're going to have an x value which is negative, it's unlikely to work. We'll see how it applies back to the question in a moment. Or we have a situation where 2x minus 7 equals 0, in which case 2x is equal to 7 and x is equal to 3.5. So seeing how those answers apply back to the question. So x is minus 5 or 3.5. Well, we can see that if I put minus 5 into this expression, I'd get a length of 0 compared to a length of 11, a length of 16. Here I get 4 lots of minus x, which is minus 5, which is going to be minus 20 plus 4, which is going to be minus 16. So clearly this minus 5 is not going to work as a solution. So the only solution is going to be 3.5. So x plus 5 is 8.5. 6 minus x is going to be 6 minus 3.5, which is 2.5. We're going to have here a length here of 11 minus 3.5. That's going to be 7.5. And then this length here is going to be 4 lots of 3.5, which is 14 plus 4, which is 18. It doesn't totally seem like it's to scale, but that's the question anyway. I mean, these drawings are never drawn accurately. They deliberately draw them wrong, so you can't assume that you can just get your ruler out and measure it, or you can just assume that it's isosceles, or assume that it's right-angled. So we have to reject this possible value, and as a result say therefore that this is our answer. X is 3.5.